Hey guys, welcome to Chapter 5. This is the integumentary system, better known as the skin. We're going to describe the structure of human skin and explain the functions of the layers, the regions, and those accessory structures. We're going to explain how the skin functions in temperature regulation, awareness of the environment, and skeletal growth. So just some fun facts about the integumentary system. It weighs 9 to 11 pounds. What? It has a surface area of 1.522 square meters. Every 1 square centimeter, so everybody just imagine like a tic tac, it has 70 centimeters of blood vessels, 55 centimeters of nerves, 100 sweat glands, 15 oil glands, and 230 sensory receptors. Guys, mind blown. New skin is produced every 25 to 45 days. That is a relative number. So just a quick overview of our integumentary system. It includes our skin and then the accessory structures. So those accessory structures are going to be the hair follicles, sweat glands, sebaceous glands, sensory organs, and there are 3 main layers. We have the epidermis, the dermis, and the hypodermis. Okay. So what does your skin do? Well, its big job is protection. It's to protect you, right? It's going to do body temperature regulation. It helps us to prevent water loss. It's metabolic, so it helps to synthesize vitamin D. It has cutaneous sensation, right? When you touch your skin, you can feel it. It is a reservoir for blood, and its job is excretion, getting rid of bad stuff, and it helps to prevent UV damage. So big one, right? Protection. It's going to protect us from chemicals, right? Now, ordinarily water, we don't really think of it as a chemical because it doesn't necessarily hurt us, right? However, if I were to remove the top layer of my skin and then put some water on it, it's going to hurt. Okay. Mechanical damage, right? When I'm grabbing a doorknob, for instance, if I were to rip off my skin and then try to grab a doorknob, it would hurt. Okay. And microbial damage, those would be any germs, pathogens. It helps to prevent us from getting sick. Also, body temperature regulation. And how do we do body temperature regulation within our skin? Well, one of the big ways that we do that is because of all of those blood vessels within the skin. Okay, so we can do what's called vasodilation and vasoconstriction. Okay, vaso, that prefix means vessel. Dilation means to get bigger, and constriction means to get smaller. Right. So vasodilation, vasoconstriction. So here's vasodilation, right? When we're really hot, we're going to send more blood flow to the surface area of our skin, to the surface of our skin. And when we do that, it's going to give us some heat loss, right? So what happens to my kids, for instance, my daughter, she's 3, she's got almost white curly hair and really pale skin. And when she gets hot, her cheeks get red. And one of that big reasons that her cheeks get red is for this exact reason, vasodilation. Okay? Then when it's cold out, okay, or we're feeling cold, we can do vasoconstriction. So we will actually reduce the blood flow to those surface vessels. And now we're going to get less heat loss across the epidermis. Okay? So let's talk about that epidermis. Well, the epidermis is keratinized, stratified squamous epithelium. Stratified, again, means stacked up. Squamous is our pancake shape, epithelium. And it is avascular. Avascular means that there are no blood vessels in this layer of our skin. The thin skin has 4 layers. What's thin skin and what's thick skin? Let's get to that in a second. Okay. Thin skin is going to be found all over your body. Okay, I'm back. I don't know what happened. I'm going to try to share out my screen again. I'm not sure if it's working, so let's try again. All right, let's keep going then. Hopefully that's working. Okay, so the epidermis. Okay. Remember, thin skin found all over your body. Thick skin is going to be found on the palms of your hands and the soles of your feet. Okay. So thin skin has 4 layers. And when we start at the bottom, that would be deep. Okay. We're going to have our stratum basal. Stratum basal. Stratum means layer. Basal means the base. Now, sometimes you may also hear this called the germinativum. Germinativum. Right? Then we have the stratum spinosum, the stratum granulosum, and then the stratum corneum. Okay. Now, in the thick skin, we have an extra layer here called the stratum lucidum. Lucidum. So again, this is thick skin. This is going to be found in the palms of your hands, soles of your feet. Here's the stratum corneum, which is much thicker. See that? Much thicker. Then we have that stratum lucidum, the extra layer. Stratum granulosum, stratum spinosum, stratum basal. Okay. Now, one thing is that you do need to memorize these layers, so it is helpful to come up with some sort of mnemonic device to help you memorize that. A mnemonic device is taking sort of like the first letter of something and making up a funny sentence or a funny word or whatever. But if you want to start at the bottom, it would be BSGLC. You start at the top, it could be CLGSB. Okay, but just come up with your own sort of way to remember that. So let's talk about that stratum basal. The stratum basal, again, is that bottom layer. It's also called the germinativum. It's the deepest epidermal layer, and it is connected to that basement membrane. Remember when we talked about epithelial tissues having to have that basement membrane? Well, there you go. Okay. This actually has what's called the dermal papilla, and the dermal papilla is going to create our fingerprints. The job of the dermal papilla is to increase some surface area, and it is unique to every person. They also help to provide blood supply to the epidermis. There is a single cell layer, and it's primarily made up of cuboidal basal cells. So that would be, if it's a single cell layer, it's going to be simple cuboidal cells, right? And that's going to create that stratum basal or stratum germinativum. Again, single layer. It contains Merkel cells. Merkel cells are nerve receptor cells and melanocytes. Melanocytes' job is to produce melanin, and melanin gives us our actual color to our skin. We also have mitosing basal cells. Mitosing means that it's making more than one basal cell in the bottom, and it's going to also have melanocytes and those Merkel cells. I don't know why I said that twice. Then we have the stratum spinosum. The stratum spinosum is actually going to appear sort of spiny when we look under the microscope. Okay? It's 8 to 10 layers of keratinocytes. Now, these are actually still those cuboidal shaped cells, but they're kind of squished a little bit because they're stacked on top of one another. So stratified cuboidal. We also have what are called Langerhans cells in here. Langerhans cells are these cells that are going to like eat bacteria, and there's going to eat some damaged cells. There's some foreign particles in this area. And we have keratinocytes in here, which are adhered together by desmosomes, and they produce keratin and glycolipids. That's going to help with sort of feeding the rest of the cells. The stratum granulosum is 3 to 5 layers of flattened cells. So we have these stratified squamous cells now. They have a grainy appearance, and the reason that they look grainy when we look under the microscope is because they have keratin and lamellar granules. The keratinocytes are dying because they are going to rise far away from any of the nutrients. Okay, remember there's no blood vessels up here. So as they start to die off, they sort of turn a little bit darker with all those extra keratin. Now, the stratum lucidum is the only found again in the thick skin of the palms, the soles of our palms of our hands, the soles of our feet, and also on our fingers. Okay, and they are densely packed with alidin. Alidin is a clear protein rich in lipids, and that's actually why a lot of times, like your palms or your soles might appear lighter than the rest of your skin. Because of those lipids. Lipids, again, are fat. And this is a barrier to water. Then we have the stratum corneum. It's the most superficial layer, and it is very thick in thick skin. It's usually 15 to 30 layers of cells, and the entire layer is replaced about every 4 weeks. Dead keratinocytes are going to happen, and we have layers of keratin and glycolipids within them. So what kind of cells do we have within the epidermis? Well, we have these keratinocytes. These keratinocytes, their big job is to waterproof, protect our skin, nails, our hair, and they're really found within that stratum corneum. Okay, we have all those dead ones up there. We have the melanocytes. Melanocytes are going to produce melanin. Merkel cells are going to, these are called slow mechanoreceptors, so they're good for light touch sensation. And then the Langerhans cells are going to be there to help with any sort of immunological defense with our immune system. Okay, so these keratinocytes are again undergoing mitosis within the stratum basal, and that helps to create all of the different layers of cells. They make keratin for toughness. They have these keratohyalin granules within them, and then we have these glycolipids for waterproofing these lamellar granules, and they actually pick up melanin as they move up to change the color of the skin. The melanocytes are the ones that are producing the melanin. They're found within the stratum basal. They synthesize melanin. That helps to absorb any ultraviolet radiation. That helps to protect the DNA of any of our mitosing cells. The ones mitosing, again, are the ones that are copying. Okay, they're doing mitosis. And their branch processes can help to deliver melanin to the keratinocytes. The Merkel cells are only found in the stratum basal. They're for light touch receptors, and we also have what is called a Merkel disc, which is in the dermis. And then we have these Langerhans cells, which are for immunological defense. These are macrophages. Their big job is to sort of like eat they're like a Pac-Man type of cell, and they're going to sort of eat anything that's bad. They can engulf and kill the bacteria. They're found within the stratum spinosum. So the dermis is the next layer after the epidermis. So we started on the top on the epidermis, and now we're going to be into the dermis. The dermis is, it has a cellular component, which is the fibroblasts. They're helping to synthesize collagen, elastin, and reticulin. We have the fibrous, which is those fibers themselves, and then the ground substance. So that tells us what kind. This is not epithelial tissue anymore. What is it? It is connective tissue. Connective tissue. Okay. So the dermis contains all the blood and the lymph vessels, the nerves, and the accessory structures like the hair follicles and the sweat glands. And it's made up of 2 layers. So we have the papillary layer and the reticular layer. So this papillary layer actually tucks up into the epidermis, right? So this dark pink is the epidermis, and then this lighter shade of pink is the papillary layer of the dermis. And then we have our reticular layer. So that papillary layer right here, it's the superficial layer of the dermis. It's made up of areolar loose connective tissue. It contains the adipocytes, which are going to be fat cells, making fat cells, and the blood vessels, the phagocytes, which are going to be cells that can eat any bacterial or viral cells. And it has some touch receptors in there, like the Meissner's corpuscles. There's a Meissner corpuscle right there. And we have these dermal papilla, which are pushing up, and they help to form these ridges, again, like our fingerprints. Then we have the reticular layer down here. Okay. This is a deeper layer of the dermis. It has some dense, irregular connective tissue, has collagen and elastin in there. It looks net-like down here. And this is actually what becomes leather when we do any sort of tanning of, not tanning like in a tanning bed, but tanning leather when they take the skin off of any animal. Not any animal. And this is also the site of the Pacinian corpuscle, which is right here. And the Pacinian corpuscle, look, it's really deep. And because it's really deep, it senses deep pressure. Fine, deep, right? So fine touch, deep. It's also where we're going to find the hair follicles, sebaceous glands, and our sweat glands. This is a drawing of the hypodermis. Okay. The hypodermis is going to connect the skin to the underlying tissue. We call it the subcutaneous layer. It helps, it's well vascularized, meaning lots of blood vessels in there. It is loose areolar connective tissue and adipose tissue, which is the fat, and it's going to store triglycerides. so that we can have cellular respiration to make ATP during starvation, thermal insulation, shock absorption, and cushion. Okay. So let's talk about some of these accessory structures. It's derived from the epidermis, but they hang down into the dermis, like their hair and our hair follicle, sebaceous glands, and our sweat glands. So it grows from the epidermis deep into the reticular layer is this hair follicle. Okay. The hair is created as a keratin filament by the keratinocytes of the hair matrix. They are located down here in the hair bulb. The melanocytes are there to deliver any pigment to the hair. We have blood capillaries here that are going to go up into the hair papilla. They help to deliver any oxygen and nutrients to the keratinocytes and the melanocytes that are hanging out in there. The hair is going to grow upward through the area of the root, and then when exposed to the surface of the skin, we call it a hair shaft. We also have this erector pili muscle on here. That's made up of smooth muscle. It's under control of our sympathetic nervous system, meaning that we can't make ourselves have goosebumps. Okay? But what it does is that it actually pulls the hair erect and gives us goosebumps. We have our eccrine sweat glands, our apocrine sweat glands, and our sebaceous sweat glands. Okay, or sebaceous oil glands, sorry. So the eccrine sweat gland right here, it produces hypotonic sweat. Hypotonic sweat is the sweat that you would think of, and its job is thermoregulation, right? We get hot, we start to sweat, the evaporative cooling happens on our skin. So that's an eccrine sweat gland. We have these all over our body. Okay. Apocrine sweat glands are going to develop in their areas abundant in hair follicles, so the armpits, the groin, and they empty onto the hair follicle just before it reaches the surface. Okay, so you can see this apocrine is going to be right here. We only find this again within the armpits, the groin area. We would not find these on the palms of the hands or the soles of the feet. So not found in thick skin. Then we have our sebaceous oil gland. This is a type of oil that's found oil gland that's found all over the body. It helps to lubricate and waterproof the skin and the hair. Okay? And it's attached to that hair follicle. So these are some of the nerves that we want to talk about. We have the Meissner's corpuscle. You can see them that they're right up in that papillary area of the dermis. They respond to touch, fine touch. We have the Pacinian corpuscles, which are deeper. They respond to deep pressure. Affini receptors or organs, okay? They're for pressure or constant touch. Merkel discs, right up here, are going to be for gentle touch. And then we also have free nerve endings. Free nerve endings sense pain. Okay. So our skin is very important for vitamin D synthesis. And in the United States, we actually, there's very few areas, especially here on the East Coast where we live, we don't actually get enough sunlight throughout the year to produce enough vitamin D for our bodies. Okay. But what happens is that we need to have the ultraviolet radiation for the skin to synthesize vitamin D. Okay. We actually get this pre-vitamin D. Okay, and we also can take in vitamin D. That all has to go through the liver to be processed, and then it's going to go in through the kidneys to then be able to be utilized for our final activation. Okay, so what we get is, it's called UVR, ultraviolet radiation. It's going to activate a cholesterol precursor and does that into what's called vitamin D3. Here it is. Okay, or cholecalciferol. Cholecalciferol is then going to go into the liver and then the kidney so that it can get activated. Vitamin D is required for calcium absorption from our food in our small intestine. So we don't have the vitamin D, then we can't be absorbing the calcium from our food within our small intestines. When we can't get enough calcium, that's going to affect our bone as well as our muscular contractions and the release of neurotransmitters. So calcium is very important to the way that our body works. Vitamin D deficiency is common in the United States due to the lack of sunlight exposure. Let's talk about these sebaceous glands. Sebaceous oil glands are going to hang off again from that hair follicle. They provide the oil for that growing hair. These are holocrine glands. What do holocrine glands do? The whole cell is going to burst releasing the oil and any cell debris, which is called sebum. During puberty, we get androgen hormones, estrogen and testosterone. They're going to cause the hair to become thicker, and then it can cause the sebaceous gland to increase the sebum production as more is needed to lubricate thicker hair. But at that point, we have these hairless follicles found on our chest, our face, our back, and sebum can then block that area without the hair, and we pull it out of the follicle. So that is going to give us acne. We also have sudoriferous glands. Those are sweat glands. Okay, and there we have eccrine and apocrine glands that are going to produce this sweat. Okay, and so remember the eccrine gland is going to go directly to a pore. Apocrine is found in those areas of the armpits and the groin. They're going to go into that hair first. So eccrine, they're found all over the skin surface. They're very small in size, and the ducts empty onto the skin surface, again, through that pore. We also can call them merocrine and eccrine, because they're a merocrine type of gland where the sweat is secreted by exocytosis. This is for that evaporative cooling, but also it creates what's called an acid mantle. So vitamin C and lactic acid within our sweat actually lowers the pH of our skin to about 3 to 5, which is acidic, and that can inhibit any bacterial growth. And we can excrete toxins like heavy metals like mercury and lead can be excreted through our sweat. Apocrine sweat glands are just found in the axillary, so that's the armpit and the genital regions, and that's the groin region. The ducts are going to empty into that hair follicle. They're very big in size. Okay. Apocrine, again, is where that apical surface is going to be pinched off in just a bit of that cell membrane into the duct. The proteins and the lipids of the cell membrane are used by bacteria as a diet, and their waste becomes body odor. Ooh. That's why we start to get body odor. It also secretes pheromones, which are the hormones of sexual attraction. And this is what happens as we age. So this is younger skin, this is older skin. And you can see that we have a lot of hyaline and water in here within the ground substance of the dermis. Okay. We also have a lot of fun elastin and collagen fibers in there. But what happens as we age is that we get less collagen, less elastin, and also less hyaluron, which is going to cause us to get a wrinkle within the skin. Let's talk about some skin color variations. Well, there's melanin, keratin, and hemoglobin, which are all sort of these colors within the skin. There's two different types of melanin. There's eumelanin. That prefix EU means true. Eumelanin is what you would probably think of as the color of melanin. It has a dark brown to a black color. Okay. Then we have pheomelanin, which is a red to yellow color. So depending on what kind of melanin your body's making gives us sort of those different shades. Okay. We also have keratin, and keratin, we find that in carrots, right? And so it has an orange to yellow color. And then hemoglobin, which is found within our blood, is actually red. Okay. And so we have these melanocytes down here at the bottom, and they are producing melanin and melanosomes. And we get those particles moving up to the surface. So depending on the amount of melanin produced and the color of melanin produced, it's going to give us a different shade of color to the skin. Okay. There's also some conditions that we can determine based on skin color. So there's cyanotic. Cyanotic means blue. And so you can see here this, I think this is a woman, her fingernails are bluish in tone. Right? That usually happens due to a lack of oxygen. There's jaundice. You can see here the whites of the eyes have turned a little bit yellow. Jaundice is yellow. That usually has to do with liver function. There's erythemia, which has to do with a sort of a red rash color. And then there's pallor, which is pale. Right? Let's talk about skin cancer. So when we're diagnosing skin cancer, we're actually looking at any discoloration of the skin, and we're going to look at those areas, and we look at A, B, C, D, E. So A is asymmetry. So is it symmetrical or not? Okay, so this is normal, this is not. Okay, then we look at the border. So are the borders even or are they irregular? We look at the color. Is there one color or lots of different colors? Is the diameter smaller than 1/4 of an inch or larger than 1/4 of an inch? And then is it evolving? How much is it changing over time? Okay, so there's different skin cancer types. There's basal cell carcinoma. Basal cell carcinoma is going to arrive from the stratum basal, and it does not usually metastasize. There's squamous cell carcinoma, which arises from the stratum spinosum, and it can actually metastasize to our lymph nodes. There's malignant melanoma. This is the one that you might be the most scared of. It arises from our melanocytes, and it metastasizes early, usually to the brain, and it's not responsive to most chemotherapies. Okay? Make sure that you understand this ABCDE mnemonic. Burns. Okay, so during burns, it actually is when the skin loses its ability to maintain homeostasis. And there's different degrees of burn. Okay, so there's first degree. First degree burn is a superficial damage caused by certain chemicals, steam, heat from a flame, or mild sun exposure. There's a deeper burn than our first degree, and this is caused by a longer exposure to those same things. So any chemicals, steam, heat from a flame, or a lot of sun exposure can cause a second degree burn. The third degree burn means that the entire epidermis can be charred or missing. This is the deepest burn. The stratum germinativum or the stratum basal is not able to heal because it's missing or in that damaged. People are susceptible to dehydration, loss of body heat, infection, and it can be caused by direct flame contact, corrosive chemicals, and electricity. And fourth degree is actually when the underlying bone and muscles are also affected. And we also talk about sort of the percentage of body that's burned. And so they've actually come up with this fun percentage area. So the head and neck is considered 9%. Each arm is considered 9%. The trunk is 36%. Genitalia is 1%. And then the lower, the legs are considered 18% each. And all of that is 100%. So again, how do we do tissue repair, right? We talked about that inflammatory response, right? So we get those mast cells coming. They're going to cause the release of histamine. And when that happens, we're going to get the blood vessels to dilate. We're going to get some more white blood cells and clotting released. And we can get a scab to form. Oops. Here's that scab forming. When that happens, we get this area of granulation. Tissue is going to sort of ingrate here. We're going to get the invasion of capillary beds, so more capillaries are going to grow up, and we can start to get some cleanup happening. Then what's going to happen is, usually this is a very deep cut, we're going to have this fibrosed area here. And that fibrosed area is almost stronger than what was there before. And so that's going to cause a contraction of the area, which leaves a scar behind. So we have all of these homeostasis or homeostatic relationships between the integumentary system and then the rest of our body, right? And so the endocrine system, it's being protected, right? So you're going to see at the top of each one of these, it says skin protects. Skin protects, right? The integumentary system is protecting all of the other systems. So that's part of that homeostatic system, right? But we also have for the endocrine, right? We talked about vitamin D synthesis, right? We talked about androgens producing the helping the sebaceous glands to be activated, hair growth, all of that, right? The lymphatic system is going to prevent any edema. Edema is swelling by picking up any excessive leaked fluid. The digestive system provides any needed nutrients for the skin. The urinary system is going to activate the vitamin D made by those keratinocytes. The muscular system is going to be generating that heat, which can increase the blood flow to the skin. The nervous system is going to be regulating the diameter of the blood vessels of the skin, activating our sweat glands, doing thermoregulations, cutaneous sensation, activating those erector pili muscles. The respiratory system is giving oxygen to those skin cells and removing the carbon dioxide. The cardiovascular system is going to be transporting the nutrients. The reproductive system, this is very evident with the females. Those mammary glands are just modified sweat glands. And so the skin is going to stretch during pregnancy. And then the skeletal system is going to provide support for the skin. So, can you describe the structure of the human skin and explain the functions, the layers, the regions, and those accessory structures, and then explain how the skin functions in temperature regulation, awareness of the environment, and skeletal growth? If you have any questions, you know where to find me. Thank you.